I'm Jack Andraka. I'm a 16-year-old high school student, and I've developed a new way to detect pancreatic, ovarian, and lung cancer that costs 3 cents and it takes 5 minutes to run. So essentially how the test works is it's a lot like a diabetic test strip. It will actually change the electrical properties based on the amount of a certain protein or a cancer biomarker that's found in your bloodstream. And so this cancer biomarker is only in your bloodstream when you have these certain types of cancers, in this case, pancreatic, ovarian, and lung. And so how it changes its electrical conductivity. Essentially, you have these long, thin pipes of carbon called carbon nanotubes, and they're an atom thick and 1/50,000th the diameter of your hair. And they have these extraordinary properties. They're kind of like the superheroes of material science. And then you have these things called antibodies. You can imagine them like a lock and key. They only react with one specific protein, in this case, that cancer biomarker. So you take these antibodies and you weave them into this network of nanotubes, such that you then have a network that only reacts with one specific protein. But in addition, it'll change its electrical properties based on the amount of protein present. So the current test for pancreatic cancer costs $800, and then also it misses 30% of all pancreatic cancers. And then also it hasn't been updated in over 6 decades. And so when I learned this, I was sure there had to be a better way. And one of the really big things that helped me in this is the fact that I was just a kid. I didn't really know anything about medicine, so I wasn't really thinking about the current limitations. And then also, what also made my discovery possible was the fact that carbon nanotubes had pretty much just been discovered like 10 years ago. One of the big reasons that the current diagnostic for pancreatic cancer, which was ELISA, the blood test, hadn't been really improved is really because there's not that much funding in pancreatic cancer. I mean, it's what we consider a rare disease. It only affects like less than 50,000 people per year in like the United States. However, its mortality is so high, killing pretty much everyone that gets it, that it's the 4th leading cause of cancer. However, due to that low incidence, no one really funds it. It gets very little attention as opposed to like breast cancer or like prostate cancer. My mentor throughout this process was Dr. Andraka at Johns Hopkins University. So essentially, once I had this idea in my high school biology class, I contacted about 200 different professors at Johns Hopkins University and the National Institutes of Health. And then essentially what happened is I got 199 rejections and 1 acceptance at Dr. Maicha's lab. And I worked in his lab for about 7 months, and he was the best mentor ever. I mean, he taught me all about scientific repetitions and doing all these different lab works. Like, for example, I learned how to culture cancer cultures as well as do the Western blot and ELISA. So it was definitely a very valuable experience. I don't think there's any advice for dealing with the rejections. I mean, like, those rejections, they stung. However, if you're confident in your idea, and then you don't really listen to them, I suppose. So there are 2 X Prizes that are currently open. One sponsored by the Qualcomm Foundation, which is the Tricorder X Prize. And essentially what that is it's a $10 million prize to develop something the size of a smartphone that you pass over your skin and can diagnose any disease instantly. And then there's the Nokia Biosensing Prize. And that essentially is actually 2 prizes, and for a total pot of $2.25 million. And so it's going to be very exciting, and there is some overlap in the teams competing there, so it's going to be exciting when we compete for these.